Thank you everyone for joining us for this insightful session. Today we're going to talk about how Quantify and Purdue Global are collaborating on building GenAI-enabled learning assistant agent. So we're going to talk about like how Purdue arrived at that problem. We're going to also deep dive a little bit into how that entire solution has been built. It is currently in progress, right? So we'll also share some insights into it. What are the pitfalls? What were the learnings from building out the solution? We have two speakers. We have Sam here. He's an executive director of learning at Purdue Global. He leads our AI task force as well. So he has been, the main guy behind like giving approvals, getting into the solutioning, and working along with the team. Then we have PD. PD is our principal machine learning architect. He's the brain behind building out these solutions. So he leads our team of developers who has actually built out this solution. I'll start with you, Sam. If you can throw a little bit of light on how did you arrive at that problem? What was your, rationale behind it? That will be helpful.
Yeah, sure. Just a quick intro. Purdue Global is the online adult learning educational arm of Purdue. So services 40,000 students plus over 1,000 courses in its degree. So they have undergraduate programs from aviation management all the way to education, MBAs, doctoral programs as well. I put this slide up here because I really wanted to emphasize that everyone learns different, right? Everyone has a different way of learning. And that is exactly the problem that we wanted to attack. We wanted to understand, first of all, why our withdrawal rates, period, were the way they were, as high as they were in our system and in any system, not just unique to Purdue. And what we found, what the data showed us, is it's confidence or self-efficacy with students. And so once we understood what the issues were, it became much more apparent to us that we needed to help students not only persist through graduation, but even course to course, and then pull the thread back even further and help them get to assignment to assignment. We have data that showed us, unique to us, that if students completed assignments versus on a 10-week term, 10-unit term, the students that completed all 10 assignments, the persistence rate through that course was almost 99%. So that's the problem we're attacking. It's the connective tissue to help build confidence for the learner and the student from assignment to assignment. And we believe the paradigm that we're building with the Quantify team at Purdue is it's critical that we develop a personalized and adaptive learning framework to support each and every student. And so that's why you see the slide up the way it is, because everyone learns different. And our goal and our vision is to create a paradigm or a platform that caters to every learner.
I'll hand it over to PD now. If PD, you can give a little bit of flavor on how did we design this solution. And as you term it, right, we are going beyond that. So it'd be interesting to know what we are doing, building the solution out.
All right. The next 3 slides will be slightly technical, but bear with me. We are giving away a lot of secrets of how we are building a learning assistant, including how we have gone to an agentic framework, right? So when we sort of like first started this entire thing, the core guiding principle or the core foundational layer was build a RAG, right? Build a retriever augmented generation system that can take any user query, retrieve the right context, generate a response, and also cite the sources, right? When I'm talking about the context here, it's all course-related documents that is sitting in your LMS, which is like, in our case, it's Brightspace, right? So that's our fundamental first piece. Now, the second thing, now, I can't emphasize more about how this is so important. So we spent a lot of time going deeper into every step of the track pipeline, fundamentally improving it through first principles. Now, once you have that in place, the second key component is having a repeatable evaluation framework. Because this is a long-term engagement and we have a long way to go, you have to feel very confident about what you're building. It's almost like a testing framework to push more and more changes into a RAG, right? So we had a repeatable evaluation framework that could test out every bit, right? From your data loading strategy to retriever strategy to generation strategy. For example, some of the hacks we took was we didn't have any ground truths. So to understand how good is the response quality, we sort of used another large language model to evaluate the response quality of an LLM, right? Like some like factfulness and harmfulness and so on, right? As a good proxy. The third key area, again, we are building learning assistant and not any other RAG pipeline. So the one key area that we focused deeply was, I would say, integration with LMS, right? The whole experience should not look like a standalone application somewhere outside, right? So it is integrated right into your LMS. Student doesn't feel alienated. While the student is interacting in the course curriculum, they can launch the entire Purdue Global Learning Assistant as a widget. So we took a lot of time to build that whole experience. And then the fourth important piece is a scalable system design, right? I would say it's a GCP conference. Everyone will talk about scalability going wide, but thanks to GCP, right? Like, so it's so easy to build a scalable, in our case, it's a microservice and not a lot of microservices, like 2 microservices deployed in Cloud Run. So all Kubernetes managed, scalable theoretically, right? But our main focus has always been, I would say, go deep rather than going wide. So instead of launching it for a lot of courses, launch it for a small set of courses, for a small set of students, but go deeper on the capabilities, because that's where the experience lies, right? So that was one key area. The other key areas I'm going to talk about is guardrail design, right? Guardrail design, I can't emphasize how important it is. And one specific area about the guardrail design is like the output guardrails, right? Like, so the PGLA as a learning assistant is supposed to give feedback. It's not supposed to rewrite an essay for you. So how do you design that, right? So we had a bunch of validators that would act on top of the large language model and would say that, okay, is it giving an answer, or is it helping the student, and so on, right? So we have a bunch of validators, and I would say we have barely scratched the surface. There's a lot of work to do on that front. Now, once that is there in place, once you have a core RAG design in place, what do you do next, right? So RAG is fundamental, foundational, but it's not enough to build a good learning assistant, right? So the next thing you do is bring in a bit of agency, right? Like, students are excited about getting feedback. Now, a RAG alone won't give you feedback, right? So you have to build an agency. So that's where we started looking deeper into the agency side of things. Can we move to the next slide? Okay, this is our hypothesis, or I would say our design principle for agency. This is not new. This is out there. Everyone might have seen it. So what is an AI agent in general, right? So I would say in the context of what we are talking about, right? An AI agent is a cognitive architecture that uses large language model to predict next set of actions, or to accomplish like higher order reasoning tasks, right? It purely does that by using a combination of what you see over here, like tools, memory, and planning. These are the 3 key components. Without that, it's very difficult to build an AI agent, right? So memory, you can think of like just like humans have short-term and long-term memory. Like in context learning or the large language model memory is like short-term, but the long-term memory is more like what we get from like a vector database. Whenever we need some context, we can get long-term memory, right? In our case, the tools are Brightspace API. So the LMS API is a very important tool. So agent having the capability to navigate the entire LMS and sort of like understand where the student is stuck in. So we have LMS APIs, we have doc APIs, like for some of the citation analysis or formatting analysis, you need to get document properties. So we have doc APIs. And the third most important piece, your retriever. So if you have a very good RAG pipeline, you have a very good retriever. And if you have a very good retriever, that helps your agency. I can't emphasize more on this because it's as good as having a great planning component. So if you have a great retriever, you would get great context, and your agency would be able to get more reasoning. Third important one is planning. I would say we have barely scratched the surface here, but some of the planning components we use is like chain of thought planning, which is more like explicitly telling to a large language model to think step by step, break it down into intermediate steps for very hard problems, right? So we have seen like large language model are very good at chain of thought prompting, like using chain of thought prompting to do higher order reasoning tasks. We use some sort of I would say, reason and act, which is like humans do, right? You observe something, you come up with a thought, and you act on it, and you go through that entire loop till you come up with some result. So we use that, and we also use something called reflection. Reflection is core to our entire agentic framework. The reflection you would see is more like system 1 and system 2 thinking. So when the agent is giving some feedback, it will reflect on the feedback and improve the feedback. This is our philosophy on how to build an agent, right? So the way we think about building an agent is use graph. To build an agentic workflow, use graph, and it's no other graph. It's a state graph. State graph can have a agent state at every node. When the graph gets executed, the state gets updated. So that's one special property. And the second property is, unlike a DAG, your state graph can recursively go back to a previous node. And actually, it can recursively call the same node over and over again. So to build agent more reliably, we think state graph is a great way to start because it gives you a lot of control. So there are 3 things happening here. We have broken down the problem into 3 pieces. There is an outer loop, there is a router, and there is an inner loop, right? The outer loop does like traditional dialog flow style state tracking, right? If user has a bunch of requirements that that he or she needs to give, then it'll start asking those questions, fulfillment questions, and so on. And the inner loop is basically goes deeper into the capabilities, right? User needs feedback, user needs API citation analysis. So we have basically broken down the problem into subspaces so that it becomes easier to solve. The other thing to note here is we do system 1 and system 2 thinking at every node. So at every node, the large language model is predicting something, and there is a slow, deliberate component that is thinking and saying that, okay, this is good, this is bad, and so on, right? So how it starts is the user will always have a query. The outer loop will have a state. And the first thing the outer loop does here, if you see, it's a little blurred, but the first thing it does is it will predict what is the next state. And the slow thinking component will say that the next state is valid or not, right? And once it is done, it will go to the router. Router will call different tools, the tools that I talked about before, right? It will call tools, or it will call the inner loop. And once it goes to the inner loop does the feedback, right? So again, the feedback is like humans give feedback. You first give some feedback, and then you think deeply about whether the feedback is good or whether I have checked against all the criteria for feedback. So we do system 1 and system 2 thinking. So the fast component is giving feedback, and the slow component is like checking whether the rules are good enough or not, right? Now, one other hack we are doing here is planning is very difficult. So we have done some pre-planning. We have offloaded the entire planning. So we have Purdue Global specific documents that can help us get some rules. So we generate rules, we pass it through some human in the loop experts feedback, right? So there are composable rules, and those are the rules that are used in sort of like system 2 thinking component, right? So it's not like the rules are generated on the fly, but we have like humans who can help us build composable rules, and those rules are used in the system 2 component, and it will see whether it's good enough.
Just to add to that, if it's okay, PD, the rules that he's talking about specifically within a writing tutor paradigm from the PGLA's perspective, which is the Purdue Global Learning Assistant. So that's what you're going to see. That's what you're hearing about. Those rules were generated by our Purdue Global Academic Writing Center. So the feedback you're going to see in a second that it's providing it's not giving them the answer. It's not generating a research paper. It's helping them brainstorm. It's a little bit of pre-flight, and it's giving them guidance and tutoring, much like a tutor would if I went to get tutoring on my writing sample. And that's what PD is referencing when we talk about the rules engine. That was human made. It arrived into the language model.
Yeah, I think that's pretty much it from the technical standpoint, right? Like, so high level, I'll just repeat, build a great RAG pipeline. When you think about agent, think of memory, tools, and planning, and use state graph for building agents.
Sam, I would like you to share, some thoughts on the vision, like where this entire PGLA solution will go, in the future phases.
We know where we want to get to. It's self-efficacy, it's confidence, it's persistence. Again, I'm not worried about graduation. I'm worried about assignment to assignment. Like we're getting super deep into how do we build connective tissue that's personalized, unique to every learner, to get them successfully through assignment to assignment. And so the vision is that it's self-efficacy. How do we build confidence in our learners, regardless of domain space? And so this is not, I want to stress, this is not hypothetical. What you're going to see, we've launched this at Purdue. It's in a pilot set of courses. It was only the initial rollout foundational version, which I call like a support shuttle. It's helping direct users to different resources, course policies, understanding their grades, navigation.
I would just like to add one point here. On the agency side, one of our core philosophy is to use two agents, one agent acting as a student and one agent acting as a tutor.